All right, hey, advanced students, we are going to be working on the areas of trapezoids, kites, and rhombuses. And today we're just going back to quadrilaterals. So we need to do a quick review on how to do several different things we've learned so far in Chapter 7. So that way, I keep hitting myself here, sorry. So that way we are prepared to kind of build on that for future classes. Now, one thing we need to remember is all of our area formulas. And you need to remember the area of a parallelogram. It's just area equals base times height. Use lowercase letters. Then we have the area of a triangle. We know the area of a triangle is base times height over 2. But also I want to remind you, an equilateral triangle, its area is side squared root 3 over 4. I'd start memorizing that one now. Plus you needed to know how to use your special right triangles, and you need to know your Pythagorean theorem. So remember, the Pythagorean theorem, you need two sides. Alright, so we need two sides in order to do it, and it has to be a right triangle. With the special right triangles, you need to know the patterns, okay? And make sure you need one side and basically one angle, so that way you know which type of special right triangle you're using. So again, if I was doing this and I was on homework, I would literally draw the two. I'd have my 45, 45, 90 right here. I'd go x, x, x root 2. I would do my 30, 60, 90, where I'd put the 30 degree there, and my short leg is x, my long leg is x root 3, and my hypotenuse is 2 times x. And I'd use those as my reference points as I'm working with this. So all these things are game when you work with these. Let's do a quick review of what a trapezoid is. Remember, a trapezoid is found, its area is found using the fact it has bases and legs. Remember, this would be considered a base, this is considered a base, this would be base 1, this would be base 2, and then I'd have leg, leg, okay? So those were our ideas when we're working behind it. Now, so the bases were the parallel sides, our non-parallel sides are called the legs, and we're going to use that to solve for area. But remember, with area, we always have to have a height, and so I really like how they have this drawn here, that the height would have to be perpendicular to the two bases, or the line containing the two bases. So you could have the height here, you could have the height over here, but notice I'm making right triangles when I do that. So strategically placing those really does help us. So let's see if you can go back to basically middle school from when you really worked with these. One way of writing it is 1/2 the sum of the bases times the height. And actually this formula is developed off of working with parallelograms, because I could take two of the exact same size trapezoids and put them together and make a parallelogram, so I could use that to solve for it. Or I prefer this one, the sum of the bases times the height all over 2. Either way, those mean the same thing, and you need to be able to apply them. Just like before, you have to make sure you always write it down. This formula you must know for calculus. You'll actually use it quite a bit, especially for semester. It's finding area under the curve. Don't worry about it if you don't know the detail in that, but this is one of those formulas you really need to know. So looking at this, we're just going to now start calculating area using the formulas. We should be able to plug and chug by now. Okay, but the problem is with this trapezoid, if you notice, this is actually the easier way to read it. Yeah, the numbers aren't as readable, but it makes more sense because now, oh yeah, I have base 1 here, and I have base 2. I'll have everything but the height. Well, I'm going to be very strategic in how I use this. Everything we've just been doing has been with right triangles. So I'm always going to draw my height in to make a right triangle. Now, remember, this whole side is 11, but now I just made this rectangle, so those two segments were the same. And that says 6. So if this is 6, what's the length of this one right here? 5. Great. So what's your height going to be? 5 blank 13. 12. That's Pythagorean triple. That's why we use it. Okay, so the height is Pythagorean triple. Now I'm actually going to leave my notes like this, because that way I can just write my formulas down straight from the information. So my area is going to be the sum of my bases times my height all over 2. Now, why would I even like the other form of it? If I have fractions. So that's why I do the other form. The sum of my bases, my top base would be 6. My bottom base is 11. My height is 12 all over 2. Now make sure you do your order of operations inside parentheses first. So I end up getting 17 times 12 all over 2. And if you do this, 2 going to 12 6 times, 6 times 17, it gives me 102 square units. Now, normally I don't put the work off to the side like this, but it's easier to see in this case for that parallelogram. But you see how the key is making sure I can draw in the right triangles, because we know they exist there, they just haven't been drawn. So I turn around and I look at this trapezoid here on the right. Again, I know it's a trapezoid because they tell you it's a trapezoid. But I'm going to use the kind of the same type of concept that we did before. But notice, again, I'm missing the height. So just like we did before with the pattern, is we draw the height in to make it. But here's the problem again. I don't know any side of that 45, 45, 90 triangle. Or do I? If you noticed before, I make this so it's a rectangle, right? So this would be 6. Well, if this whole side is 11, what's left for this side? 5. Well, what do we know about the legs of an isosceles right triangle? That's right. They're congruent. So this leg is also 5. Now, do I have all the information that I need for that trapezoid? Yeah, I have the height and the bases. So again, we're writing our formula down. Base 1 plus base 2, that's a new word, base 2 times the height all over 2. So we have base 1 is 6, base 2 is 11, height is 5 all over 2. So I get there, 17 times 5 all over 2. Well, that 2 doesn't go into either one, so I have a fraction here. So I get 85 over 2 square units. They didn't give me a measurement, but make sure it's area, so we label it. Are you guys starting to see some patterns here? Let's look at the next one. I love this one. This one takes a little more work, but it's not too bad. Notice on the next one, I'm missing a base. But what type of trapezoid is that one? We know it's a trapezoid because they tell us that. It's going to be an isosceles one. Well, those base angles are the same. Well, I'm going to draw this because I know they're the same. That should be my 60-degree angle right there. Do you see the two smaller right triangles that are going to help me figure it out? I know this segment from here to here is 3, but I still somehow have to calculate what the rest of my height is and what the rest of my base is. Well, this is a 30, 60, 90 triangle. That should be 60 degrees. This right here is my right triangle. I know the hypotenuse. I need to get to the short leg. Well, how do I go from hypotenuse to short leg? You divide by what? 2. So that's 3 over 2, which makes that one exactly 3 over 2. Well, then what's going to be our height? Our height ends up being the short leg times root 3 to get our long leg, right? Because our long leg is our height. So that's 3 root 3 over 2. I'm just using my 30, 60, 90 triangle. Now that looks kind of nasty. Well, this is when actually writing the formula out like this goes easier because it's going to be easier to work with fractions. So if you have fractions, that's the better way to write your formula. But remember, what is the bases? I have a base here of 3, and I'm going to let that be base 2 because I always do the bottom one's base 2. But what's base 1? Well, that's 3 over 2 plus 3 over 2. Well, what does that all add together to be? Get a common denominator, that's 6 over 2. Right? So I get 6 over 2 plus 6 over 2, which gives us what? 12 over 2, which equals 6. So that one base is just 6. That's just knowing our fractions. Then we plug in everything we know. Okay? My area is 1/2 the sum of my bases. I'm going to have base 1, which is 6, plus base 2, which is 3, but my height is 3 root 3 over 2. So make sure those are all over 1. It makes your life a lot easier. So I get 1/2 of 9 over 1 times 3 root 3 over 2. Now, numerators multiplied together, denominators multiplied together. I get 27 root 3 over 4. In this case, it's area, so it's squared units. Now remember, I can do work backwards problems with these too. Let's do another one real quickly. Again, I'm actually not going to flip this one. Hopefully you realize this is still a parallelogram here. This would be base 1, and over here would have to be base 2, and I don't have a height again. Now, if they gave me this segment, I do have a height, because it's the same value, but they didn't. So this makes this a 45, 45, 90. Definitely not drawn to scale. Trust your numbers. And yes, that 45 should be there, but give it credit, have to be drawn in. I need to find the height, and I need to find the length of the base. So I really need to know the length of these two segments. Well, I have the hypotenuse of an isosceles right triangle. I divide to get to length. What do I divide by? Root 2. So 9 root 2 divided by root 2 is what? 9. Now, what do I get here? The height is 9. What's my base here? If this is 9, oh look, I made a rectangle again, that's 6. Base 2 ends up being 15. Am I correct? Good. So now, let's go ahead and plug it into our formula again. The sum of our bases times the height all over 2. Notice I don't go b1 plus b2 times h. No, I say the sum of our bases times the height over 2. It lets me know what they represent. And again, rules plug and chug correctly. So I get 6 plus 15. My height was 9 all over 2. So I get 21 times 9 all over 2. What do we get? 189 over 2 square units. Hopefully that will help us on the first page, and then we're going to keep practicing some of the other ones.